indefinite integration, right? You all have done indefinite? Okay. So indefinite में क्या किया था तुम लोगों ने कि अगर एक फंक्शन है कैपिटल fx जिसका डेरिवेटिव स्मॉल fx है, so then this implies the indefinite integral is what? Capital Fx plus. ये किया था? This is the indefinite. Okay. Now, ये बाकी सब करने जरा settle down. Now, you all have seen definite integration, right? You must have seen this in physics. Now, first what I will do, I will write down the statement first. उसके बाद मैं समझा दूँगा what is the geometric meaning, how it came and all that. Okay. Now, you all have seen the definite integration in physics, and the definite integration of fx from a to b. You all have seen this is f of b minus f of a. If this is the antiderivative of small fx, then the definite integration of fx from a to b is given by this. जो भी limits हैं a and b, okay? This is the lower limit, this is the upper limit. That is fb minus fa. Now, before we actually get into the chapter, थोड़ा geometric meaning, let's get into that first. Okay. Now you all have heard of this, the geometric interpretation of the definite integral. What is it? It's the area under the curve, right? It is the area under the curve. Suppose you have, this is the graph of suppose fx, okay, and there are two lines, x equal to a and x equal to b, okay, and this area that you have over here is fb minus fa or integral a to b fx dx. Now how did this come into origin? ये ऐसा होता क्यों है? Let's see that. You all have done this in physics, no? अभी जितना भी मैंने बताया सब physics में किया, but I will tell you why. Okay? See. लिमिट्स में डेरिवेटिव का मतलब क्या होता है? जैसे अगर हम बोले कि fx का डेरिवेटिव ये, it means what? Limit h tends to 0, f of x plus a, f of x plus h minus fx upon h क्या होता है? fx. Is that clear? That means for h being very small, I can say that f of x plus h minus fx is equals to h times fx. ऐसा हम कह सकते हैं. For h being very small. Okay. Now what I'm going to do, suppose ये small fx का ग्राफ है. Small fx का ग्राफ है, and I'm interested in finding the area between fx, the lines x equal to a and x equal to b. I want to find this area. So what I will do, I will partition the entire region into like these vertical lines. Okay. So like the number of partitions are so large. This is first partition, second partition, third partition. ऐसे करते करते this is the last partition. Okay. Now the partitions are made so small that we can approximate these areas as rectangles. Okay, that means obviously if you're taking a curve, then you can see this height and this height may not be the same, right? The two heights. But if you take the partition to be very small, then you can see approximately there it's a rectangle. Okay. Now let's say each interval is of length equal to h. Okay, which means that if this on the axis is a, this on the axis is a plus h, then this point over here is a plus 2h. This point is a plus 3h, a plus 4h, and so on. h का intervals है. And let's say at the end, finally, जब हम b पे पहुंचते हैं, that b is actually a plus nh. Okay, a plus h, a plus 2h. After many times, we get b, which is a plus nh. Now, what do you think will be like the typical value of n? Will it be very small? Will it be something finite, or will it be very large? N will be very large. N is sort of indicating the number of partitions, number of divisions. So n has to be very, very large. So if h tends to 0, n will tend to infinity. Is that clear? Okay. Okay. So what I'm going to do, I'm going to approximate this area. I'm going to say that this area is what? What is this area? We'll approximate every rectangle, every partition as a rectangle. Now, what is the area of the first one? Like, देखो, ये A है. Area of rectangle is length into breadth. अब हर rectangle का width हमने क्या लिया? H लिया. So the width is H. Height क्या है? What is the first height? We can take it as f of a. This height is f of a. Okay. So the first area would be f of a into h. Now, what would be the second area? अच्छा, यहाँ पे a plus h है. So this height is okay. I will need some space. एक काम करो, पहले copy करो. I'll draw a bigger diagram. The same diagram, no? Now, are you done copying the right side also?
Yes.
One more minute. So, like I said, the first area can be approximated as f of a into h. The second area can be approximated as, like the second area में second जो height है वो f of a plus h. So the second area can be approximated as f of a plus h into h. And the third area में yeah, f of a plus 2h into the fifth. Yeah. Okay. And so on. Now, what do you think will be the last area? जैसे a plus n minus 1h. So this would be f of a plus n minus 1h into h. Is that clear? This would be the last area. And now we add them up and that gives the total area. Now, this would be the total. Achha, now suno. We know this relation. H into fx is f of x plus h minus fx when h is very, very small. Right? Very, very small. So I'm going to use that. And देखो, ये जो expression है ये क्या है? h into a मतलब x को a डालो. x को a डालो क्या आएगा? f of a plus h minus f of a. यहाँ पे x को क्या डालो? a plus h डालो. So we get f of a plus 2h minus f of a plus h. Then a को x को a plus 2h डालो. So we will get ऐसा एक series आएगा. ठीक है, ऐसे करते करते लास्ट में क्या आएगा? f of a plus nh minus f of a plus n minus 1h. This is a what? It's a telescoping series. So when you add them up, this total matlab this is the total area. And what happens when you add this? Only the सब कुछ कट जाएगा. Only this term and this term will remain. Correct? कट गया. Okay. So what is remaining? F of a plus nh minus f of a. And what is that? FB minus f of a. Okay? So now I have actually proven that the area under the curve is actually FB minus FA, where F is what? The antiderivative. Is that clear? Antiderivative समझते हो the word? ठीक है. Now, area जो होता है ना, वो हमेशा it's always the algebraic area. So the definite integration is what? It's the algebraic sum of the algebraic area under the curve. Now what does that mean exactly? Which means that अभी देखो, अगर in the simple case, suppose अगर fx ऐसा है, a to b ऐसा है, okay, and let's call this area as a1. The definite integration will be a1, right? Integral fx from a to b is going to be this area. But suppose if your function is negative, suppose this is my g of x, is going from a to b, and g of x is negative, it's below the axis. So this, let's call this area as a2. The definite integration, which is integral of g of x from a to b, will actually be negative of a2. So when in cases where the function is negative, the area, the value of the integral will come out to be negative, but area तो positive ही होता है. Therefore, the magnitude will come out to be the same. It's just that the sign में difference होगा. Is that clear? Okay. Have you written this part? Yes. So one more thing now. Suppose you have a function which is like this. It's sometimes positive, sometimes negative, sometimes positive again. Okay? And let's say this portion is area 1, this portion is area 2, and this portion, let's say, is area 3. The definite integral will be what? Any guesses? In terms of A1, A2, A3. Yes, it will be A1 minus A2 plus A3. See, when you integrate this part up till this portion, the integral is positive. When you integrate this much portion, it's positive. But the integral from here to here, since the function is negative, the integral will come out to be negative for this portion. Okay? But areas are always positive, keep that in mind. So the definite integral will be A1 minus A2 plus A3. Is that clear? Whereas it comes from a property which we will do later on only, like integral from A to B, which I will do later on. You can divide the intervals. Okay, this is something we'll do later on, but do you know this property from physics? इसमें किया है? Nice. ऐसा कभी किया है physics में property? No, it's like this. It's like this. It's like this. If you have A here, B here, and C here, then integral from A to B is basically integral from A to C and then integral from C to B. Yeah? It will be this portion plus this portion. So it will be A4 and A5. And this portion, this integral, is actually A4. And what is this portion? The second portion? Second integral? From C to B. So it is what? A5? Minus A5. Minus A5. Okay, just trying to show. Minus A5. Okay. So this is just some basic relation between integrals and areas. Okay. Just copy this part. We'll do all these properties of line se karenge. I just wanted to show you the area wala relation. Copy everything. find the definite integration. So I think you already know this. Physics में किया होगा कि you find the indefinite integration and then you put the limits, right? Now suppose you have integral of x sin x dx from 0 to pi by 2. First find the indefinite integration. How do you integrate this? By parts. Okay. So when you integrate this by parts, क्या करोगे? किसको इंटीग्रेट करोगे? हाँ, x को डिफरेंशिएट करेंगे, इसको इंटीग्रेट करेंगे. तो जिसको डिफरेंशिएट करते हैं वो पहले बाहर होता है, माइनस इंटीग्रल डेरिवेटिव एंड फिर इंटीग्रल पूरे पे dx. So integral of sin x is minus cos x. It becomes minus x cos x, and this is 1. This is minus cos x. So it becomes integral of plus cos x. मतलब minus cos x आ गया, वो minus minus को मैंने plus कर दिया, and then integral of cos x becomes sin x. So this becomes x cos x plus sin x. Okay. So now this is अच्छा plus c तो आएगा ही indefinite में, but when we calculate the definite integration, now we will put the limits on it. Minus x cos x plus sin x पे हम limits डालेंगे pi by 2 and c. Okay. So that means when you put the limits, first I'll calculate f of pi by 2, then I'll calculate f of 0, and I will subtract. So what do I get? Minus pi by 2 into cos pi by 2, which is 0, plus sin 90, minus, जब 0 डालोगे तो सब 0 हो जाएगा. 0 plus 0. So what's the answer? The answer is 1. Now, problem actually comes in when you use by parts. So by parts का जो formula है, just wanted to demonstrate this. So integral suppose a to b fx gx. Now normally when we use by parts without the limits, क्या आता है? Suppose we are integrating gx. So fx into integral g of x minus integral sr, I suppose. SR है. अच्छा, ये normal है by parts. When I put limits a and b, is this right? Is this right? ऐसे तो limits पहले पे डाल रहे हैं, तो उस पर भी डाल दो limits. हो गया ना? Is this right? Why not? Wrong है तो क्या पेन? कहाँ wrong है?
पूरे fx और gx का जो इंटीग्रल होगा उस पे लिमिट्स लगेंगे, बट यहाँ पे जो आपने लिखा है उसमें वो नहीं हो रहा है ना.
हाँ, अच्छा सी देखो, when we put limits, okay, see, अगर हमने definite integral indefinite निकाला, the indefinite integral will always be a function of x, but when as soon as you put limits तो value constant आती है ना, 90 and 0. Okay. Now here, if you notice one thing, this is the definite integral, which will come out to be some constant value. But fx है ना बाहर, so it's still dependent on x. So that's the catch over here. Now, when you're calculating definite integral, पहले पूरा function निकालो. देखो, fx into integral gx is a whole function itself. उस whole function पे हमें limits डालना है. That means we have to put limits on this entire function dna. मतलब calculate this function fx into integral g, that will come out to be new function. फिर उस new function पे b और a डालना. Is that clear? Okay. So that's the problem. So by parts हमें ऐसे करना है. Is that clear? Okay. Now कई बार ऐसे होता है when we are trying to find the definite integral, then we run into a lot of problems. So suppose you're finding this fx dx a to b. Now ये हम अगर ढूंढ रहे हैं, sometimes what happens is कि जो एंटी डेरिवेटिव है fx है, the anti derivative capital Fx may not be defined at a or b. Okay, it may not be defined, शायद उसके डोमेन के बाहर होगा. In that case what we do? तो देखो उसको ऐसे करते हैं. Suppose अगर ऐसा है कि फंक्शन है fx a to b एंड हो सकता है a और b पे कुछ पंगे हो, या तो स्मॉल fx डिफाइंड नहीं है या तो कैपिटल fx डिफाइंड नहीं है. हाउ डू वी डू दैट? सो सपोज a एंड b पे आई जस्ट पुट अ नॉट ओवर हियर, मीनिंग कि a और b पे कुछ प्रॉब्लम है, मे बी आउटसाइड द डोमेन. देन दिस थिंग, अच्छा हो मे बी a पे डिफाइंड नहीं है बट a प्लस पे तो डिफाइंड है, a के थोड़ा आगे. ओके, सो आई विल राइट दिस एज f ऑफ b माइनस f ऑफ a प्लस. व्हाट डज दिस मीन? b के थोड़ा पहले a के थोड़ा आगे, इट माइट बी डिफाइंड, जिसको हम ऐसे भी लिख सकते हैं, लिमिट x टेंडिंग टू b माइनस लिमिट x टेंडिंग टू a प्लस. हो सकता है कि उस पे डिफाइंड ना हो बट उसका लिमिटिंग वैल्यू एग्जिस्ट कर रहा हो. ओके, आई विल गिव एन एग्जांपल ऑफ दिस. ओके, आई थिंक बोर्ड भर गया है बट आई विल गिव एन एग्जांपल. इंटीग्रल ln x dx फ्रॉम 0 to पहले कॉपी कर लो. ठीक है, अच्छा, you all know what's the definite integral of ln x?
x
Indefinite, minus x plus c भी आता है, that's okay. ये इसको कैसे इंटीग्रेट करते हैं? 1 लेके ना, 1 into ln x लेके फिर वो 1 को इंटीग्रेट करता है, ln x को डिफरेंशिएट करता है. Now when we are finding this problem है, because अच्छा when we put the limits, when we put the limits 1 and 0, 1 के लिए तो ठीक है, 0 के लिए प्रॉब्लम है. ln 0 क्या? ln 0 is minus, टेंडिंग टू 0 लेंगे तो टेंडिंग टू माइनस इंफिनिटी होता है. ln 0 is not defined. So instead of taking 0, we take 0 plus. 0 से थोड़ा आगे. ठीक है? Now जब 1 डालोगे क्या बनेगा? 1 into ln 1 minus 1. Now I'm not going to put 0. What I'm going to do? I'm going to put limit x tending to 0. ठीक है, ये ले और इसको सॉल्व करेंगे. नाउ ये कितना हो गया? ये 0 हो गया, ये माइनस 1. दिस इज माइनस 1 माइनस ऑफ, नाउ दिस ये तो सिंपल है, लिमिट ऑफ x इज 0 है ना. सो आई हैव टू फाइंड बेसिकली लिमिट ऑफ x ln x. ये कौन से फॉर्म का है? 0 into infinity. ln 0 is tending to minus infinity. And 0, so 0 into infinity. How to do this? How to?
So ln x by 1 by.
हाँ, you use हाँ, इसको ऐसे लिखेंगे ln x upon 1 by x. L'Hopital's rule लेके differentiate करते रहो. It becomes infinity by infinity. So just keep differentiating. This becomes 1 by x minus 1 by x square, which is x only. It becomes minus x. Now minus x की limit 0. Put x as 0. So the answer is now simply minus 1. Is that clear? So whenever we encounter a case where अगर 0 डाल ले तो problem है, तो 0 ना डालो, limit extending to 0 in place of exact 0. Is that clear? Now number 5. Suppose you have, this is A, this is B, fx, assuming fx is positive. Now integral fx a to b dx, suppose अगर area है A, then integral b to a fx dx is minus a. meaning integral a to b, integral b to a is the negative of integral a to b. You know why? अच्छा देखो, inside the integral there are two quantities. एक fx है, एक dx है. Now I told you कि अगर fx the function is positive, the integral will come out to be positive, right? Because the area will come out to be equal to the area. And dx जो है वो मतलब that is also another quantity. When you take the integral from b to a, that means you're going from b to a. What is happening? We are going backwards. X is decreasing. Now if x is decreasing, dx is negative. You can think of it like this. Okay? So if dx is negative, fx is positive, so therefore the इनका जो product आ रहा है वो negative. So from b to a it's actually negative. And this is one property. Integral from a to b is negative. Integral from b to a. Okay? Is that clear? Okay. Now, sixth one. अच्छा कभी-कभी क्या होता है? Sometimes in the function, you have a function like this. You have a discontinuity in the function of this sort. This is A. This is B. Let's say this is C. This is a discontinuity in the function. Okay? So what we do, how to integrate such a function? The integral from a to b will be the integral from a to c. Now हो सकता है कि it may not be defined at c. हो सकता है कि c पे defined ही ना हो, c के पहले just defined है, c के बाद just defined है, for some reason. So instead of writing a to c, I will write it a to c minus. मतलब a से लेके c के just पहले वो वाला area, and then the second area c plus से लेके. Okay, that's the second part. That's how we split the integral into two parts. और इससे तुम्हारा क्या right answer आएगा? ऐसा हो सकता है कि इससे wrong answer भी आ जाए. So whenever you see a function is discontinuous in between, तो ऐसा check कर लो, ठीक है? We'll give an example of this. पहले पूरा copy कर लो. अच्छा let me tell you first कि ऐसे टाइप के केसेस बहुत कम मिलेंगे और हम स्टार्टिंग ऑफ द चैप्टर ही में तुम्हें सारे इस टाइप के एक्सेप्शंस बता दूंगा. अच्छा ऐसा होगा. So don't be मतलब you'll obviously end up being a little more over cautious. Majority of the problem ऐसा नहीं हो रहा है that you'll see. ठीक है? But फिर भी you have to watch out for such kind of things. Now suppose you have something like this. Suppose you have to integrate something like this. Now, suppose you do it like the normal way. Okay, हम करते जाएं. अच्छा dx कट गया है. हाँ, it's not something done actually. Actually, you can do that. So it becomes see, integral of du is u, right? Right. So when you sort of take this out, it becomes integral of d of something, right? So integral du is what? U only. So what is the integral of this? This. And then you put the limits 1 and minus 1. Okay, इससे आंसर wrong आएगा. Okay? Not because I did this, but for some other reasons. So when you put the limits, you get what? 1 by 3 plus 1 minus 1 by 3 raised to minus 1, okay, plus 1, ऐसी कुछ आएगा, ठीक. This answer is wrong. उसके पीछे एक रीजन है. उसका रीजन ये है कि ये जो फंक्शन देख रहे हो, it's discontinuous where? At 0. At 0 it is discontinuous. So what I will have to do is, I will have to split the interval from -1 to 0 and then 0 to 1. So -1 to 0, but 0 मैं लिखूंगा यहाँ पे क्या? 0 plus की 0 minus. 0 minus. Yes. Okay. And then from 0 plus to 1. Okay. And अभी क्या होगा यहाँ पे? ये वही सेम थिंग कैंसिल करो. Integral du is u. So what you get? 1 by 3 raised to 1 by x plus 1, 0 minus 2 minus 1, and then you'll have this. ठीक है? Which is what? 1 to 0 plus. Okay. अच्छा, 0 minus क्या होगा? f of 0 minus क्या? 0 minus डालूंगा तो क्या होगा? What is 3 raised to 1 by 0 minus? 3 raised to minus infinity, which is 0. Which is 0. What is 3 raised to 1 by 0 plus? 3 raised to positive infinity, which is infinity. Okay? So over here, when you put 0 minus, this thing becomes 0. Okay? Of course, जब मैं -1 डालूंगा, I will get this. And now let's see what this is. 1 डालूंगा तो I'll get the same thing I got here. 3 plus 1. 0 plus डालूंगा क्या होगा? This thing becomes infinity. Denominator becomes infinity. So the whole thing becomes 0. So you can see, although this minus this भी है, but एक additional term भी है. Plus 1. So that's the difference. That's the correct answer. Is that clear? Anyways, so that was just one example I've shown you. Now, एक और चीज है. I have shown you biparts कैसे handle करते हैं.
Yes.
In different degrees. There's another trick that is used in integration, which is substitution. Now, substitution में भी कभी-कभी problem आ जाता है. So I'm just showing you कि where all you can go wrong. Okay. So substitution. Now there are 3 points that you have to keep in mind. I will reveal those 3 points after I've shown you the example. Okay. But first let me give you the example. 0 to 2 pi dx upon 2 plus sin x. How do you solve this question if the limits weren't there? Definite integral कैसे करते हैं? Indefinite integral कैसे करते हैं? Any idea? How do you do this? Anybody tell me? Come on. बोलो बोलो. क्या?
The sin x को
Sir, sin x minus 2 से ऊपर से divide करो.
अरे come on.
sin square x by 2 plus cos square equal to
नहीं. हम लोग tan x by 2 को पी लेते हैं. ठीक है? Okay. हम लोग ये करते हैं. Now sin x is like 2 theta. So 2t upon 1 plus t square हो गया. And इसका जो डेरिवेटिव होता है, I think 6 squared x by 2 into half into dx is dt. I differentiate both sides. So dx क्या है? 2 dt upon 6 square. And 6 square is 1 plus tan square. मैं रट्टा भी होगा कहीं. 6 square is 1 plus tan square, 1 plus t square. 2 dt upon 1 plus t square. ये होता है? Okay. So now we substitute. Okay. So what happens? 2 pi 0 2 dt upon 1 plus t square. And this becomes 2 plus 2t upon 1 plus t square. So then you get 1 over quadratic. 1 over quadratic को हम integrate कर सकते हैं. So I think I'll just simplify it. I think after 2 minutes, I think it comes out to be something like this. ठीक है? इसके बाद ये हो गया simplify करके LCM लेके. अच्छा. After another 2 minutes, I think you will get it something like this. Perfect square complete करना आता है, right? So you'll get something like this: t plus half plus root 3 by 2 का. Oh, by the way, I forgot to mention one thing very important. देखो, you all want to integrate this. हम तो अभी definite integral निकाल रहे हैं. I just got carried away with the whole substitution. But substitution ये करना आता है सबको? Okay. One thing I forgot to mention. When you are making a substitution, okay, what is this x? X is the variable of the integration. X is the variable of the integration. Now, when you do a substitution, the variable changes. From x, it has become t. So, t is now the new variable of integration. Now, जो limits होते हैं, they are what? They are the limiting values of x. X is going from 0 to 2 pi. हम इसको ऐसे बोलेंगे. X is going from 0 to 2 pi. Now, when we change the variable to t, we must write down what? The limits of t. T must go from what to what? We cannot write the limits of x over here. That would be wrong. So, it's very simple. See, t, there is a relationship between t and x. So, if x is 0, what is t? Tan 0? Yeah, tan 0 is 0. Now, if x is 2 pi, what is t? Tan pi, which is also 0. So, what are the limits going from? 0 to 0. Okay. Now, I actually don't need to solve this. I actually don't need to do this. I just got carried away with the whole thing. But otherwise, we're getting this. And the limits are 0 to 0. What is the answer?
Should be
0. Yeah. You must remember that integral a to a fx is going to be 0. Why? Because see, when you take integration is after area. Yeah. So now a to b अगर बोलो तो ये area हो गया. But लेकिन अगर b और a same हो गए मतलब this is shrunk and this is shrunk into a line. This is in the new diagram. So a to a से start हो रहा है a पे खत्म हो रहा है. Line का area क्या होता है? 0. Okay, so you just shrunk this. So when the upper and lower limits are same, the area is 0. So over here, this area is going to be 0. Now that is confusing. That's a bit odd. Why? Because देखो sin x plus 2 क्या है? It's positive. Sin x plus 2 always positive होता है. एक positive function को integrate कर रहे हो, answer 0 आ रहा है. Is that really possible? Because if you have a positive function and you integrate it between 0 and 2 pi, let's say, तो उसका area क्या होना चाहिए? Positive होना चाहिए. Are you understanding this? So there is a problem, no? There is a problem. कुछ तो गड़बड़ है. क्या गड़बड़ है? बताओ.
So अगर हम लोग solve करेंगे तो maybe infinity minus infinity ऐसा होगा.
Okay. Okay. Maybe. Problem क्या हो रहा है यार? Sin x plus 2 एक positive function है. If you integrate a positive function, उसका area integral जो है should be positive. Limits also going from 0 to 2 pi. Okay. ऐसा सी, अगर ऐसा कोई function होता है ना, जो कभी positive हो और कभी negative हो, ना हो सकता है कि ये area positive आता है, but this integration, the second one, its value is negative, so कभी positive कभी negative, net sum 0. But positive function का area positive आना चाहिए. अब इसका 0 क्यों आ रहा है? Come on, tell me. Give me 1 minute time to think. अच्छा, first of all, is the answer right?
0.
Is the answer right? answer right.
So when we did the substitution, there was a discontinuity at pi by 2. For pi by 4 or 2.
At x equal to pi.
Huh.
Correct. हाँ. Okay. This answer is actually wrong. Okay. Now let me explain. Substitution जब हम करते हैं, you need to keep 3 things in mind. I'm going to list down all those 3 things. ठीक है? So the first thing that I told you was, when we are making a substitution, okay, change the limits appropriately. Right? So जो limits पुराने वाले limits है that corresponded to the old limits, and these new limits have to be for the new variable. So that's the first thing you need to keep in mind. Now I come to why this is wrong. Okay? All of you written this? No. Left part? Oh, I love it. Any doubts so far? Apart from जो भी है वो मैं बाद में बताने जा रहा हूँ कि ये wrong क्यों है. All of you written the left side at least?
Yes, sir.
Okay, so let me just complete the explanation for this. So here we go. Problem is, जब हम substitute करते हैं t as tan x by 2, this variable tan x by 2 जो हम substitute कर रहे हैं, it's discontinuous at x equal to pi. When x is pi, this is tan 90, so हो गया discontinuous. Okay? So that's the problem. So the second thing that we need to remember is that the new variable should not be discontinuous in the interval. Okay? Now, how to actually correctly do this? We can split the interval into 2 parts. 0 to pi and then pi to 2 pi. Okay? And then I will make the substitution. Let t be tan x by 2. Okay. Now when I do that, then जो अंदर की क्वांटिटी वो तो सेम आएगी जो हमने पहले निकाली थी, है ना? This substitution, all this is same. I think you will get dt upon 1 plus t square जो मैंने पहले निकाला था वहाँ पे. Substitution करने के बाद, now limits क्या डालें? When x is 0, t is 0. When x is pi, actually we won't take pi. Why? Because it will become tan pi by 2, which is not defined. I will take tan of pi minus. So we'll get t as tan pi by 2 minus, which is what tending to infinity. अगर एंगल को 90 से थोड़ा पहले लो तो tan की वैल्यू is tending to infinity. So t will be tending to positive infinity. So it goes from 0 to infinity. ठीक है? This is the first one. Now the second one, if you see the second integral, when you take x as 2 pi, what is tan x by 2? 0. Tan pi. And when you take x as pi, now this time I won't take pi. I will take pi से थोड़ा आगे. Pi plus. What is tan of 90 plus? Negative infinity. 90 से थोड़ा आगे जाएगा तो second quadrant में जाएगा. Become negative. So it becomes minus infinity. So the second integral becomes minus infinity to 0 dt upon 1 plus t square. This all I have explained before. वो कैसे आता है इसको लिखोगे. And now you integrate it. Okay, how to integrate it? वो उसको ऐसे लिखोगे. Perfect square complete करके. Okay, let me just integrate this first. Plus whatever. What is the integral of this? What is the integral of 1 by x square plus a square? 1 by a. 1 by a. Tan inverse x by. And then I will put the limits. Infinity 0. Same thing over here. I think the function is the same. So same thing, and then I will get over here 1 by root 3 by 2. Just copy, just continue copy. Now I don't have anything to explain. I just write down the answer, but first copy everything. But you understood what was the mistake, right? When you are substituting the new variable, तो new variable should not be discontinuous. और अगर discontinuous है, तो फिर उसको intervals में split करना पड़ेगा. If t is discontinuous in somewhere between, you have to split it. Is that clear? This is going from 0 and minus. I'll fill that up. पहले copy कर लो पूरा.
So 1 plus t plus c square सबसे
क्या हुआ? अच्छा नहीं, ये ऐसे करो ना इसको. वैसे तो इसको सॉल्व करो आगे. You'll get this. LCM लेके करो, 2 कैंसिल कर दो. क्या इसका आंसर तो वैसे 0 आता है, which is wrong. Because the limits are the same. Otherwise, okay? Now when you put infinity, tan inverse of tending to infinity is 90, pi by 2. Minus, now when you put 0, what happens? What happens when you put t as 0? 1 by root 3. So 1 by root 3 मतलब 30 degree, pi by 6. Okay, then we come to this one. तो इसमें सबसे पहले 0 डालेंगे. तो 0 डालेंगे तो क्या आएगा? अच्छा 2 by root 3 तो है ही. 0 डालेंगे तो वापस pi by 6 आएगा. Now what happens when you put negative infinity? What is tan inverse of tending to negative infinity? Tan inverse of tending to minus infinity is minus pi by 2. Okay, it's minus pi by 2. I hope you all know that. Yes. So this becomes minus pi by 2. So I think इसमें हम ऐसा लिख सकते हैं. Just write this part. The answer is what? 2 by root 3. I think the pi by 6 gets cancelled. The answer comes out to be 2 by root 3 pi. Okay, so this is the answer. Fine. Now the third point that I'm going to mention is very rarely used. I mean, you can sort of ignore it. Anybody have a doubt? Okay. Third point is very, very insignificant. Most of the cases, in fact 99% of the cases, I don't know. So what is the condition? The new variable and old variable, okay, must have a 1-1 relation. Okay. Yeah. Anybody has a doubt? Hit enter. Okay. इसके examples मैं तुम्हें बाद में देता हूँ. ठीक है? And I'll explain the statement slightly later on. Let me get to some important points. I think we were on hash 7 or 6 or what? 6, 5. अच्छा 8th वाला तुम्हें indirectly already बता दिया है.
ये 7.
अच्छा ये 7th. Okay. Okay, we have 20 minutes left. Let's quickly mention this to you. 7th वाला मैंने तुम्हें already indirectly बता दिया है. अगर एक function है which is greater than or equal to 0 in the interval a to b, then उसका integral भी क्या होगा? Positive होगा. Is this obvious? Function अगर positive है, उसका integral भी positive है. Of course, I'm assuming b is greater than a. Then the 8th question. अच्छा, अगर suppose there are two functions, fx and gx, and in this figure you can see in the interval a to b. So in the interval a to b, कौन सा function बड़ा है? g of x बड़ा है. तो अगर g of x बड़ा है, तो integral g of x will be bigger than integral fx. है ना? Because the area is much larger, as you can see. Fine? ठीक है. Okay. This part. The very basic examples which I just want you to try. Just copy this and try whatever I'm asking you to. सिंपल है. अच्छा, questions may not fall in the exception. बस ध्यान रखना है तुम्हें खाली.
Sir,
One second.
sir,
हाँ बोलो.
sir,
Yeah,
okay.
tell me. It's 5/3. So we might not complete all questions. जितने भी हो जाएंगे attempt करो, देखो. Now first one you can either use substitution या तो say one person said first find the indefinite integral. Now if using substitution हम सबसे पहले tan x को हम t लेंगे. ठीक है? तो obviously 90 पे तो not defined है. तो हम क्या करेंगे 90 plus लेंगे. ठीक है? So what will be the new limits? So if tan x is t, sec square x dx is dt. Right? So this is your dt. What will be the new limits? देखो x अगर pi है, tan of pi is 0. x अगर पाई बाई 2 प्लस है, tan क्या है? माइनस इन्फिनिटी. So the limits are going from minus infinity to 0 e raised to t dt. ठीक है? And then this will be e raised to t only. And the limits will be 0 and minus infinity. So e raised to 0 is 1. And e raised to, actually we will not write e raised to minus infinity, it's obviously e raised to tending to minus infinity, which is 0. So this is actually wrong, actually it should be written limit t tending to minus infinity e raised to t, and this is going to be 0, so the answer is 1. Okay? Now the second one, how many have done it? Okay. Second one. Okay. In the second one, there are many ways to do this question, many ways to do this question. I'll do this. Wait, I think by now you should have done this question, so I won't wait. Now, there are many ways. Now, one, तुमने वो कैसे किया? Tan से किया?
cos divide करते हैं.
अच्छा, उसकी जरूरत नहीं है. वैसे you can do it by different way. What you can do is sin raised to 4x plus cos raised to 4x को वो वाली identity होती है ना? This is 1 minus 2 sin square x cos square x. Now, can you write this in terms of sin 2x?
Yes, sir.
Yeah, this sin square 2x is 4 sin square cos square. So this becomes sin square 2x by 2. Acha. Now I am going to write it like this. Sin 2x twice upon 2 minus sin square 2x. ठीक है? Now sin square को convert करेंगे cos square में नीचे. So this is going to become 0 to pi by 4. 2 sin 2x, 1 plus cos square 2x. 1 minus sin square and 1. Okay, now what I will do, what substitution?
So 1 2x
Cos 2x को t ले लो. ठीक है? Cos 2x को t ले लो. Now differentiate, तो minus 2 times sin 2x dx is dt. So this numerator part is actually minus dt. ठीक है? And cos 2x is t. Now when we are making a substitution, we will also change the limits. Now if x is 0, what is t? Cos 0 is 1. Okay. When x is 45, t is cos 2x, cos 90. 0. So limits are now 0. And this becomes minus dt upon 1 plus t square. Okay. अच्छा, what we can do, sometimes ये minus थोड़ा कचरा हो जाता है. What I can do is, I can invert the limits and take care of the minus sign. ऐसा मैंने बोला था limits a to b and b to a are negative of each other. ये limits 1 to 0 तो उल्टे direction में जा रहे हैं ना. We can make it like this. Limits 0 to 1 and get rid of the minus sign. And do like this. Now the simple integral is just formula based है. Just tan inverse t and ये जो limits है ये t की limits है. Is that clear? So what's the answer? Tan inverse 1 is pi by 4. Tan inverse 0 is 0. So this is pi by 4. Is that clear? That's the answer.
So pi by 2 plus pi infinity कैसा?
What?
So pi by 2 plus first question.
First question में क्या?
So pi by 2 plus को t minus infinity plus infinity आना चाहिए.
सर वो बोल रहे t plus infinity होना चाहिए, pi by 2 plus.
ये कौन है? कौन से सेंटर में? Which center? Which center? हाँ, tell me which center? कौन है ये? बताओ. अच्छा, बोलती बंद हो गई. अच्छा, so I guess you don't have any doubt then. कौन कह रहा है pi by 2 plus के लिए? बताओ, शक्ल दिखाओ यार अपनी. अच्छा फिर भी मैं समझा देता हूँ बंदा जो भी है यार टैन का ग्राफ देखा है कभी जिंदगी में? कौन है? आई डोंट नो हू टू मेक आई कांटेक्ट विद। टैन का ग्राफ देखा होगा तो आई ड्रॉ दिस पार्ट। टैन का ग्राफ ऐसे होता है, ये 90 होता है। 90 पे क्या होता है? नॉट डिफाइंड होता है। 90 की जस्ट पहले क्या होता है? पॉजिटिव इंफिनिटी। 90 के जस्ट बाद क्या होता है? Okay, can do the other 3 questions. अच्छा ये वाला तो कैसे करेंगे? tan x by 2 को t लेंगे, right? You know ना 1 upon tan x by 2 को t लेंगे। इसमें कोई डिसकंटिन्यूटी नहीं है। हाँ ठीक है ठीक है। Now when you take tan x by 2 as t, कि यहाँ जो लिमिट्स बनेंगे 0 to infinity हो जाएगा। tan 0 0, tan 90 के थोड़ा पहले, तो मतलब 90 के थोड़ा पहले भी आएंगे, so infinity, and this would become 2 dt upon 1 plus t square, right? वो तो ऑलरेडी पता है। and cos x क्या होता है? 1 minus tan square upon 1 plus tan square. I'm sure you've done plenty of this. ठीक है ना? This is what you do when you do the substitution. And I guess यहाँ पे 1 by 1 plus t square, 1 plus t square दोनों denominators same आएंगे. I think you will get something like this. 1 plus t square plus cos theta into 1 minus t square. So what you'll get is 2 dt 1 plus cos theta plus t square 1 minus cos theta. Now what I'm going to do is this. We can take 1 minus cos theta से हम divide कर सकते हैं। Okay, divide this by 1 minus cos theta. You can take it common out. Because theta is not, see, देखो, theta is a constant, right? So, integration में constant को हम बाहर ले जा सकते हैं. So, I'm taking this common out, and what I'm actually getting is 1 plus cos theta on 1 minus cos theta plus t square. ठीक है? So, this becomes integral of 1 upon x square plus e square. Actually, अगर देखा जाए तो इसको हम simplify कर सकते हैं. And actually 1 minus cos theta का formula है ना 2 sin square theta by 2, है ना? And जब ये वाला अगर term देखोगे, numerator क्या है? 1 plus cos theta, 2 cos square theta by 2, and this is 2 sin square theta by 2. So what is the ratio? Cot square theta by 2 plus t square. So this is integral of dx upon x square plus e square. ये formula लगा देंगे, which is what? 1 by tan inverse x square. Okay, so that will be 2 है 1 by a tan inverse x by 1. और अभी हम t की लिमिट्स डालेंगे 0 to infinity. Is that clear? सबको ये ऐसी कुछ समझ रहा है ना? Okay. Now it doesn't really matter what happens because infinity डालेंगे तो tan inverse infinity will be 90 और 0 डालेंगे तो tan inverse will be 0, है ना? So ये वाला part simple है and I guess we get the answer over here. What is sin square into cot theta by 2? Yeah, it's it's sin theta into cos theta. This product. Cos by sin and sin. एक sin कर जाएगा. हाँ. So it becomes sin theta by 2 cos theta. And this part over here, it becomes tan inverse infinity minus tan inverse 0, which is what? Pi by 2. Yes. This becomes 2 upon sin theta into, this is sin theta, no? 2 sin a cos theta. Pi by 2 minus 0. So the answer is pi upon sin theta. Is that clear? Okay? सबको समझ में आ गया? Okay, that was a very interesting exercise. This is a small exercise, and pay attention over here. I'll give you time to copy. Which one is bigger? Sin cube x का integral या sin raised to 5x का integral from 0 to 90?
Sin cube x.
This is bigger. Why?
So because sin less than 1 minus 1 is less than.
This is bigger because sin x lies between 0 to 1. The higher power you take of sin, it will diminish more. So sin cube x is bigger than sin raised to 5x. So जो function बड़ा होता है उसका integral भी बड़ा होता है. Is that clear? ठीक है? Okay. The next one, B. Only answer बताओ.
Tan raised to 5x.
Tan raised to tan cube x या tan raised to 5x?
Tan raised to 5x.
From 45 to 60.
5x.
Tan raised to 5x. Why?
No, tan raised is.
Yeah, because if x is between 45 and 60, x is between the limits, no? 45 and 60. Then tan x जो है वो greater than 1 होता है. For x between 30 degree and 45 degree and 60 degree. So in that case, tan raised to 5x would be greater than or equal to tan of x. Is that clear? Okay. So therefore this function is bigger. Okay, the C part.
Cos first one.
Cos दोनों functions cos raised to 5x है, cos raised to 5x है, both functions. Only difference is this is pi by 3 to pi by 2. This is pi by 3 to pi.
First one.
Any other answer? Why first one?
Cos raised to 5 negative values.
It is negative.
नेगेटिव हो जाएगा.
Yeah, actually अगर देखा जाए pi by 3 to pi जो होता है that is integral pi by 3 to pi by 2. Then pi by 2 to pi. Now you are integrating this function cos raised to 5x. So these intervals मतलब ये first quadrant वाला angle है, तो ये जो quantity आएगी positive आएगी. But when you integrate from pi by 2 to pi, yeah, cos is negative. So cos raised to 5 is also negative. So this integral, this portion will be negative. So definitely this is bigger because this means what? To this you are also adding a negative quantity, so it will decline. So this is bigger. Is that clear? Okay. हो ही गया है. Okay. So I mean we'll continue this next time. You have a booklet or something? Have you got the booklet?
Yes sir, we have got it.
Anybody has the
Integration.
booklet right now? Anybody has the booklet right now with you?
सर
बोलो.
सर आपने वो थर्ड क्वेश्चन में थीटा का रेंज क्यों मेंशन किया 0 to pi?
Okay. See, नहीं, that was just so that कि ये जो है first quadrant में आएगा theta by 2. Okay. Booklet है किसी के पास? Anybody has a booklet? अरे कोई booklet चाहिए मुझे integration. Yeah, please get your booklets next time.
Yes sir.
So at least I can. There's one booklet for the entire. अच्छा, next time we go fully fledged into the chapter. अभी थोड़ा सा बस exceptions बताया क्या है, जो भी प्रॉब्लम्स हो सकती है
Polycom
वो
का
बताया।
button दबाओ,
थोड़ा
कौन
बेसिक
कौन
चीज़
है?
है।
इधर बटन दबाओ उसको, पॉलीकॉम का बटन दबाओ।